Hi, I'm Nico. We're going to talk today, me and Matt, about adding pattern matching to Kotlin. So, tiny bit about me. I am a student at Imperial College London. I just started working on my second startup, blockchain.com, also based in London. So in this talk, feel free to stop, feel free to send a message if I'm going too quickly. As you should know, there's a slight stream and a delay, but again, I have no feedback with my public. So I will assume no knowledge of pattern matching. So if you've never heard of it, I think this is actually a good place to start. And well, let's jump right into it. So if you're developers in Kotlin, you might have come across code like this. So there's a few problems with this, and you do not need to understand everything that's going on. But here are the main takeaways. We have a really big when clause, and it has nested branching. In particular, it has 4 branches, but actually 1, 2, 3, 4, 5 cases, 3 branches in 5 cases. So the problem here is we have duplicate branches and a lot of nested constructs. In particular, we have a nested when and 2 nested ifs. And all we actually want to do here is just, we have some data and we're looking to see if it fits a model we expect, i.e., does this data look this way? And if so, can I do something accordingly? So this is just branching, and we do this all the time in programming. And turns out there is a very popular construct that exists in other languages that allows us to inspect data and just branch out depending on that. So in Kotlin, we do this most of the time thanks to when, if, and sometimes polymorphism. And if we apply pattern matching to Kotlin, potentially it could look like this. There was a lot going on the other slide, and this is supposedly exactly the same thing. So I'm going to really slowly go through what is going on here so you can get an idea of all the stuff that potentially could be added to the language. So let's start with the stuff we know. Here we're looking at just a regular when clause. We're checking whether our download, which remember could be either an app or a movie, is either of both. And if you inspect the seal class, both have a name, a title, and then an app may have a developer, which may be a person or not. So here we check if our download is an app, and that's the usual type check. And then we can destructure. So this would work pretty much the same way it already works in Kotlin. We can just depend on our extension functions, component 1 and component 2, to look at the values inside our download. So here we are calling component 1 in the download. So this is, again, it's hypothetical. This is not valid Kotlin, as you know, but we're exploring the possibility of how it would be if this was a valid Kotlin. This is where it gets fun, because here we just destructured our first component, but here we can do a type check on the second component. So this is a recursive check. So the same thing we were doing with our download and the type check of an app, we are doing with a download component 2 and a type check of a person. So here we are checking the developer. So is our developer a person? Then again, we can carry on destructuring. We don't care about this bit, so we can just use a wildcard. And here, an equality match happens, so not a type check. So again, this was a destructure. So this is component 1 of our developer, and we're just checking whether the name matches Alice. So based on all this, from one line, we know our download is an app. It was developed by Alice, and Alice is a person. Additionally, we extracted name, which is just the name of the app. And so we have a branch. And then the next branch is exactly the same. And the third bit is also interesting, because here we have a fallback. And it's a fallback where we have exhaustiveness, i.e., if a download is either an app or a movie, this is covered. And since it is a seal class, it can only be an app or a movie, right? Therefore, if Alice was to write a book, we would not be able to miss it. So the way pattern matching works is we check this pattern, does it match? No, we check the next, does it match? Then we check the next. And note how all duplicate branches before are now a single branch. So if this was some complex error, we would only have to do it once. Now, this is nice. We did type checking, we did equality checking, we destructured, but there are some more things we'd like to do. Ideally, we'd like to match on anything, not just like equality or just a type. So for that, we'd like more constraints. So take a look at this example. This I borrowed from the code base of TornadoFX. So it's actual code just running in real life. A lot of you might have used it. So what goes on here is the same thing as before. We have a when, nested if, and we have two cases. So if we were pattern matching here, what we would ideally want is have one entry for a JSON array that is empty and an entry for a JSON array that is not empty. But instead, we are forced to have a single entry for a JSON array and then inside do an additional check. So what we could use is something called a guard. A guard is a construct that allows us to guard against the match, i.e. it protects the match. So in here, we check if it's a JSON array. If it's a JSON array and it is empty, then we can go carry on with this branch. And otherwise, we can carry on through this branch. So note how this actually looks a lot like what we had before. How is this not a nested if, right? So that is an interesting question, and we'll come back to that in a bit. But otherwise, you see the rest of the cases are the same, because in this example, we do not really care about equality. We only care about the type of what we're checking in, and in this case, whether it's empty or not. So note how this is a smart cast as well. We can only check whether an array is empty. We cannot check whether a JSON element is empty. So that was also nice, but when we code, it's not always that nice. Why? Well, we don't always deal with data classes. We don't always deal with destructuring, we know. In particular, with regards to the first example, we're using data classes. They have component 1, component 2 functions, and it's a sealed class. That's not always the case. So take this example. A lot of going on. You don't need to stop to think about all of it. But the main takeaway is that we're checking a class that is not ours. So this is an actual class from AWS Lambda. It's a library. It's a Java library. And as Kotlin developers, we often have to actually deal with Java libraries. So this is code we had to write. What we're aiming to do is just route requests that come to us as this input parameter. And we want just to call functions on them depending on how they look like, right? So for example, take the first one. When our path is invites and the method is get, just create an invite, right? Just because we just getting the invite. Anyway, what's the problem with this thing? So again, nested whens and repeated paths. And we'd like to destructure on it, but this is not a data class. But good thing, destructuring actually comes with component end functions. So what we can do is just define extension functions, which most of you know, I'm sure, and match in a class that is not Java, that is not Kotlin. So what is this? This is just another pattern match, and we extensively use guards to check on the method. So this is where this example is really different from nested ifs, because we don't have an else clause after an if statement. And this is fundamentally different from the if-else expression in the Kotlin language as it is now, in that when you write if as an expression, you are forced to write an else. This does not happen in pattern matching. These are cases, and they're checked one by one. And if one doesn't match, you just carry on to the next, whether it's a guard or not. So here we check for our API gateway proxy request event, which we know to be true because we're checking on that. We destructure a quality check on the path, extract the method, extract the body, check whether the method is equal to either get or post, and then call functions accordingly. And if it's not equal to either, we can carry on and match against a different path. Whereas if we were using nested ifs or nested whens, we would be forced to handle the case where the method doesn't match here. But that's not happening here. Here, it falls back to this one, which also won't match. So we will fall back to this one, so we can fall back to our error. So here we have a single path to handle our fallback case. So you might have noticed that we know the type of an 8-gate of an API gateway proxy request event. So why would we need to type check an API gateway proxy request event? The short answer is we really don't. So we could just skip that type and just leave a wildcard. And the wildcard itself could be omitted as well, since we're only interested in the destructuring and the equality check. So this is when the when clause starts looking really different from what you're used to, because we're not even doing a type check. We're doing a pattern match where we don't care about the type. So we decided to omit the type. But we still get all the other benefits. We're just typing less stuff. So that was pretty much it. That's pretty much the idea that I currently have of what pattern matching in Kotlin could look like. But we should compare that to the state of the art in other languages. In particular, functional languages have done pattern matching really well for years now. And it's just a really popular feature. It's tried and tested, and it's very idiomatic. So how would that compare? Well, let's take a look at this example. So this is still Kotlin. We have a simple CL class. It's just an option. It's either some int or nothing. And through guards, we're just checking what the int looks like, if it's there, and if it's not there, just a different message. So we have 4 cases here. And here we're doing it with 2 matches and 3 guards. And we'll just 2 guards and the else case. So Scala does it very similarly. You could read Kotlin, you could still read this. We're just matching on result and extracting X from each of the matches. So Scala has guards, but it only has 1 at a time. Whereas here, we could kind of chain the guards and not have to rewrite some every time. Still very readable, 4 cases. This is Haskell. So I'll go really quickly over it because Haskell is very different in syntax from JVM languages or C-like languages. But this is the same we had before. This is a match. We're matching on something. And this is guard. So this means if, and this means otherwise, as you can read. So again, not much to say here. When we evaluate this with sum3, we'll get the case we expect. And Java. So some of you might be surprised to see Java in this comparison, but Java is actually considering adding pattern matching. And if you've used JVM, so the Java 15, you've seen a really early preview of this, which is pattern matching in instance of, in if-else. So eventually, there's several proposals, draft of GEP proposals, where pattern matching could be added to the language. And this particular example is taken from Brian Goitz's blog. And he wrote several of this, pretty much all of these drafts. So if you've used Java, you can read this. And this is what a switch case, a switch expression with pattern matching could look like in, say, Java 15, 16, or 17. And the drafts also mention adding guards. So in practice, the Kotlin pattern matching we just imagined could become reality in Java in some years, and is actually on its track for that to be the case. So this was nice. We kind of managed to be on par with existing solutions that are really popular, and they're just tried and tested, except the Java one, and have been there for several years. In Haskell, it's the way to do control flow. But can we do better? So can we be more original than this? Can we come up with nicer stuff that maybe fits better into Kotlin than just the already popular idea? So there's several possibilities for this. First off, the syntax that you've seen, you should not stick to it too much. I just wanted to discuss the idea and the semantics of a possible pattern match. So could the syntax look more nicely? We always like good syntax. Can we have nicer guards, like maybe have guards as a function of lambdas and compose them, like we could compose functions? How do we destructure a data class with 10 fields? You can imagine what that would look like. We just have to like add wildcards for every single one of the fields. So in particular, Scala is kind of having this problem. Could we match outside of a when expression? Like, why not match in an if? So all these questions, well, we have to agree on them. And all of this is up to debate. This and all we've discussed so far, there's room for improvement. So how do we add all of this idea? How do we add it to the language? How do we get pattern matching in Kotlin? So one way is to ask nicely and submit a request, a keep. So I wrote keep 213 a few weeks ago, where I discuss all of the slides I just showed you and some alternatives and extensions. And I hope at some point the Kotlin team will consider adding it to the language. So if you haven't seen it yet, go take a look if you have enjoyed the talk I just gave. It has several real-world code examples where it shows how pattern matching could benefit the code base. It has some possibilities, some syntax alternatives. So if you like this idea and you like to see more of it, you're welcome to take a look, comment, leave feedback. You like it, say so. You don't like it, say so. But there's another way of adding pattern matching to the language, is making it ourselves, if the Kotlin team is not up for it. So I hope you enjoyed the talk. And now we're going to talk, Matt, my friend, is going to talk to you about how we could just bake it into the language. Thank you.
So yeah, we're going to talk today about doing this as a compiler plugin, and going to actually share my slides as well. All right, I'm going to start with a little quick story time here. When I started this whole process, I knew some things about compilers, but I was not an expert of the Kotlin compiler. So my story on this was discovering Nico's Keep, which I was very excited about, and I wanted to make this possible. As he mentioned, the Keep is the sort of nice way of asking, but we wanted to experiment with this as early as possible. And so after conversations with Nico and Raul Raja at 47 Degrees and a few others, thank you for your help, we kind of decided, let's bring this into Aerometa and start it as a compiler plugin. And the nice thing about that is you guys can start experimenting with that during this year as we're working through it and getting it ready. Yeah, I also wanted to just point out that if you're not familiar with the compiler, and there's not a lot of documentation out there on this, so it can be tough, please do join the Kotlin Link Slack and ask questions. People are very friendly there, and that really helped me trying to figure this out as I started. So yeah, not a compiler expert, limited information. There's almost nothing you try to Google on this stuff, you're not going to find it. Equals help. So please do reach out for help on Kotlin Link. All right, so why a compiler plugin, and why are we not doing this directly in Kotlin? Again, as Nico mentioned, trying to get this in the compiler is going to be kind of a long process, right? When you add features to a language, you need to get buy-in from the community. And there's a lot of folks in the Kotlin community who are very interested in this and have been for a while. But some folks maybe don't feel comfortable with it right away. You need to make sure that that language feature fits in with the rest of the syntax and the semantics of the language. And we'll discuss how that looks with the underscore for the wildcard matching, as Nico had shown you. So doing this as a compiler plugin allows us to kind of experiment with what syntax looks right, what semantics work right. I actually see there's a question here, which I'm going to just quickly address. If you define component extension functions on a class that is already defined as a data class, will the compiler use the most local definitions? The answer to the question is we don't yet know. This is something we could do, and I'm actually really happy that you posted that question, because, and I encourage people to post questions on this. We want to try to figure out what you and the community actually want to see with this new feature that we're bringing to the language, what makes sense with scoping and other questions like that. Aerometa, I want to talk about this for a little bit. You can build compiler plugins without Aerometa if you want to use the internal compiler APIs. The nice thing about Aerometa is that it provides us with a lot of features out of the box, thanks to the work that Raul Raj and others have done over there at 47 Degrees. features that make building compiler plugins just that much easier. And so Aerometa just made perfect sense in this case. We're actually hosting the current code for this in Aerometa at present. Also, you would get inclusion in the Aero ecosystem. So if you are already planning to use Aerometa, you could just automatically out of the box get access to pattern matching as part of that, rather than having to go install yet another compiler plugin. The other nice thing about using Aerometa is there's advanced type features in there. Roland and Simon have been working on a lot of interesting features around type proofs. And some of those things would become useful for us to enable us to automatically have access to things down the road outside of the box. So overall, Aerometa was just kind of the perfect fit for what we were trying to do with this. So let's talk about the plugin itself. The plugin, sort of at its core, is broken down into these 4 main steps that we're doing. We have here enable IR. Now, IR, for those not familiar, is intermediate representation. And basically what this is in the Kotlin compiler, especially as we move into version 1.4, we're going to start seeing some changes in the compiler where instead of just directly using ASM, which is what's typically used to generate Java bytecode, we're going to have this layer between code generation. Code generation would be the stage where you actually get your bytecode for whatever target you're targeting, whether it be the JVM or native, anything like that. So IR sort of helps make that process a little bit easier, and it is the future moving forward. Consequently, in this plugin, we actually want to turn that on. Now, the plugin's running on version 1.3, 1.61, I believe, currently, of the language, which we're currently restricted to that within Aerometa because of changes that we're waiting for in 1.4, which, from what I understand, should be coming out soon. So we turn IR on, and that lets us do a little more interesting things. The next step is, we're dealing with pattern matching. We've got these different symbols we're going to add. So we have underscore here in this case. The underscore does represent a wildcard, as seen in Scala. And if you just stick that into your IntelliJ, you'll notice that it's going to show up as an error for pattern matching because it's not yet defined. And that's, of course, what this plugin is doing, is defining what that means. So we need a way to suppress that error. Any of the errors that come up from these new semantics that we're going to add in for this syntax. The next stage, of course, is the analysis phase. The analysis phase is interesting because that's where a lot of the deeper stuff takes place, with things like type checking, resolving the expressions, so the underscore as an expression. So that's a piece that we're spending a lot of time on to try to figure out the best ways to handle those things. And then finally, once we get past the analysis phase, we have the IR tree transform. So again, once we've gone through this whole process, after we've enabled IR and we've gone through the rest of the process of type checking and everything else, the IR tree, we may need to also make changes. So that basically means we'd be rewriting the tree structures that the when expression, for example, would output into forms that we could, that the rest of the compiler could understand as it generates bytecode. So that's the basic overview. Let's take a look here at one of the issues we ran into when doing this. So the underscore in this case, as this is a sort of shortened version of what Nico is showing you. The underscore in this case is difficult because underscore in Kotlin, of course, represents unused parameters, and we need a way to separate that out, right? We don't want to collide or clash with Kotlin's existing underscore semantics. So we needed a way to actually separate that out and say this is marked off as our underscore for pattern matching, but don't affect anything else. And one way we did this is, if you look here, we have the case keyword, which I'll make larger here. It's a function. And that's a way to actually separate that off and mark it out so we know what that's for. So case is you might be wondering where it's coming from. It is a new function that we've added in the plugin. And it literally just, in fact, I believe I have an example here. Yes, we have a We're calling it a synthetic function. Basically, it's a function that really does nothing. It just takes a parameter in of any nullable type, and it returns any nullable type. And you can see here, it just equals arg. That's it. It's literally just a way to mark off, hey, everything in these parentheses should be pattern interpreted as pattern matching in the semantics. Here you'll notice when trying to look at using case, we had some issues with the parser. The interesting thing with a plugin for a compiler is you can't modify like all of the syntax, right? You're still stuck with what the parser understands as valid syntax. But we're trying to rearrange that. And so one of the first things we tried was taking this case keyword and putting that in without the parentheses. And of course, you'll notice over here on the right, this is a PSI viewer, which has been very helpful in figuring this out. We start getting all kinds of errors out of this. We can't parse these things correctly. So that didn't really work. And of course, the answer was to just move to turning this into a synthetic function. And as you'll notice here, the difference between these two, we go from errors to now it's cleanly parsing at least. So yeah, that clears up the underscore as a reserved keyword. It also safeguards and protects it for our use case, while not affecting Kotlin's existing semantics. The other issue we run into here is suppressing warnings for the underscore. So the compiler will throw an unresolved reference. Let's say we got case, that's matching fine. We've got the underscore now sitting in there, but the underscore does throw that error. It doesn't know what underscore means yet. And before we even get to the point where we can start defining what underscore means, we had to actually alter what it refers to and change its type. If looking at the underscore, we notice that it has a null type, which is useful because it's a way for us to also further ensure that we're not clashing with the existing underscore semantics in Kotlin. So that combined with case, that was enough for us to determine that this is our case to modify. So the first stage of this, once we've gotten those errors suppressed, is to start resolving type information. This happens during what's called the analysis phase, as I mentioned earlier. So we can go in there and we can check on the expression underscore when it comes through, and we can actually verify, yeah, the type is null. We can backtrack in the tree to see whether or not it's wrapped inside a case, just to further restrict that down. Once we've gotten that, we've found those elements for underscore, we can then record in the analysis phase what the type of the expression is. So if underscore refers to like first name, which is a string, we would record that underscore in this case should be a string. And then the next step after we get the type information recorded is we want to record the actual the reference that it would refer to. For example, this is where the destructuring with component one, component n, etc., would be used. We can say this is going to be a function that looks up some property of a class. All of this information is something we can do through binding trace and binding context. These are calls that we can use. With binding trace, we can get all the information we need at compile time to look up things through the tree. And then we can use the binding context to actually write those expressions, all the type checking and everything. That goes back through the binding context. And just to kind of give you a little overview here, this is the code at the high level for the pattern matching plugin. Is not very big. It's a little bit misleading because some of these functions, particularly down here, resolve pattern expression and the wildcards function that we pass in there. There's actually a bit of code going on behind that. But in a nutshell, I just wanted to show you that this is actually not that hard to do this at the high level. Here we have analysis phase. We're enabling IR, as I mentioned, as our first step, suppressing diagnostic. We're getting rid of those unresolved reference exceptions for underscore. And then we proceed with the type checking process that we need to go through and resolve those expressions. So it's actually not that hard to throw together a plugin in this fashion. The real question is, does it work? I've been talking about all this stuff, and that's great, but let's have some evidence that this is actually going to work. Let's find out. I'm going to do a little demo. So I'm going to switch over here to screen share my IntelliJ instance. All right, so here we are. You'll notice I have the case synthetic function in here. We don't at present actually have that being auto-written by the compiler at compile time. So I've inserted that in here for the time being. However, we do have this case with the actual wildcard in here that I mentioned. And we have, we are pulling the first name on the match, and we're going to return that. And then let's print the result. So let's actually see if this works. I hit run up here, and it works. It prints my name. So that's about all we have working right now. It's still heavily a work in progress, and we can switch that, by the way. We can do underscore on the first name, last name. Either case works at present. Some of the more advanced stuff around nesting and guards. We don't have guards yet included. So we still have to figure that part out, but it is in fact working. So I just wanted to, again, give a special thanks to all the folks who have really gotten this kicked off with us. Raul Raja, of course. Nico, thank you. Andre, and I don't know if I'm pronouncing your last name correctly, but Shaikov, I hope I'm saying that right. He's been indispensable in understanding some of the compiler internals with the expressions and how to do some of the type recording. So, and many others have helped us. Really do appreciate it. If you want more information on this, here's the keep, which Nico had already told you about. Our pull request is up on Aerometa, so feel free to check that out. It's PR 651. We're on Kotlin Lang Slack at the pattern matching channel. And there's Nico and my GitHub and various handles. So that's about all I have, folks. I hope you find this interesting. I hope you follow along with us. And please do share and let us know what you think.
Thanks, Matt. Thanks, Nico. We have one question. I'm not sure if you can see it.
Should I answer?
Oh, yeah. If you want.
So
go for it.
We are aware pattern matching was discussed, and like you say, it was pretty much avoided. So the remark, I just watched the clip, good thing that you sent it. The remark that was done is that it is a difficult question, and there was a bit conditional, which is if Java ever ships it. So a year and a bit later, we are seeing Java is completely on track to actually ship pattern matching. So the conditional is there, and there hasn't ever been like a proper discussion about it. So there has been no keep. So if pattern matching gets thrown away, that's completely fine. That's completely fine. But that should not happen before having a discussion about the possibility of it and all the ways it could come about and what shape it could take. Maybe we're just imagining it the wrong way and we're just waiting to someone to come along and just come up with a proper way of doing it.
Yeah, not much to add to that. Exactly. I just back up what Nico said. This is kind of a learning experience for us to figure out how to do this the right way for the community. And again, to echo what Nico said, please join in on the keep and throw your suggestions or thoughts in there, because that helps us figure this out too. So